Welcome everyone to our first panel of the year. Can we design growing media mixes to protect our peatlands? Peatlands are a vital component in the UK's habitat, locking in billions of tons of carbon, protecting land from flooding and preserving biodiversity and even history in some cases. But these rainforests of the UK are under threat from human activity. Today we will hear from 3 experts about the efforts to protect peatlands, with a particular focus on whether designing unique growing media mixes can aid in the fight to save these important ecosystems. We'd love for you to follow along on social media during the panel. Please tag RSK Group and use the hashtag Green Dialogues. You can find us on Instagram, LinkedIn, Facebook and Twitter by searching RSK Group. Before we start, a few housekeeping notes. All attendees' microphones are automatically muted throughout the webinar. During the sessions, you can pose questions, and there will be a Q&A session at the end of all the presentations. As many questions as possible will be answered, and those that can't be due to time constraints will be answered after the webinar. Shortly after the session ends, you will receive a link to a short survey. Please do take a few minutes to provide feedback so we can improve on our future webinars. So now we have time for our first panelists, Chris Forster-Brown, Associate Technical Director at ADAS. Chris, if you can join us. Hello.
Hi.
So Chris specializes in habitat management, the impact assessment of large renewable developments and policy reviews. He has a keen interest in botany and ornithology and has many years' experience of British and Irish peatlands. Chris, I will leave you to get us started.
Thanks for the introduction, Lucy. So I'm going to speak about peatlands as a valuable resource. If I could just have my first slide up, thank you. And by the term resource, I don't mean one that should be used entirely for our benefit, but one that should be valued for a variety of reasons, and in particular for its biodiversity and carbon sequestration properties. So peatlands are found over much of the UK and Ireland, but particularly widespread in the north and west of the country, coinciding with those areas that are cooler and have the highest rainfall. So there's obvious concentrations of them in mid and north Wales, in the Pennines, and much of northern and western Scotland. And very extensive examples are found in the far north of Scotland, in the flow country of Caithness and Sutherland. In fact, the flow country is considered to be the largest expanse of blanket bog and peatland in Europe. Extensive areas are also found in the Western Isles and in Connemara in Ireland, and this picture here shows a large area in Connemara dominated by blanket bog. There are 3 main types of peatland in the UK and Ireland, and these are blanket bog, which tends to develop in sort of low-lying hollows and on shallow slopes and flat surfaces. Raised bog, which develops when a water body fills with vegetation, and fens, which tend to develop on shallower peats and are often associated with lake margins. Blanket bog tends to be found in the uplands, though it can come down to sea level in the far north of Scotland, and raised bog and fens tend to be found in the lowlands. Now, the UK and Ireland have approximately 20% of the world resource of blanket bog, and they're also extremely important for the other 2 peatland types, so raised bogs and fens. Next slide, please. So peatlands provide a wide range of benefits. For example, they cover such vast areas that they can make up a large percentage of the landscape, giving it its character. And Seamus Heaney is quoted as saying that the bogs in Ireland also provide the memory of the landscape. And this is because they're excellent at preserving things. Most developed between 5,000 and 6,000 years ago, and because of the anaerobic conditions, are able to preserve all kinds of archaeological evidence. This varies from pollen grains through old trackways, jewellery, and occasionally whole human bodies. Many of the artefacts in Irish museums have been recovered from peat bogs. They've also been used extensively for fuel, particularly in Ireland as turf. And fen vegetation such as reeds and sausedge, particularly in East Anglia, have been used widely for thatching. Peatland soils have also been a major constituent of compost, and my colleagues will be talking in much more detail about this. They're also important in terms of flood alleviation, acting as giant sponges in some situations. But perhaps their two most important properties are their biodiversity value and carbon sequestration. Next slide, please. Turning first to peatlands' biodiversity value. So they're important for birds. This includes breeding waders such as dunlin and golden plover, with particular concentrations in northern England and Scotland. And in Scotland, these are joined by greenshank as well, and Britain supports a high percentage of the world breeding population of this species. Characteristic birds of prey found on the peatlands are merlin, hen harrier, and short-eared owl. And small lochans in the peatland also support breeding red-throated divers. Peatlands are also important for invertebrates and particularly for beetles. And also in terms of plants, some examples of fens, including the one in the photo, are very species rich in terms of plants. Much of this is because they tend to be rich in minerals, and particularly calcium and magnesium. Some of the more acidic bogs are not as species rich, but they do support a variety of scarce species. Next slide, please. So classic species of peatlands include bog rosemary, bog asphodel, bog myrtle, and cranberry, and this is cranberry in the photo. It looks like a small cyclamen with its turned back pink petals. It's nestled in amongst bog moss, also known as sphagnum, and it's this sphagnum that provides the majority of the peat-forming material. Traditionally, sphagnum has also provided a key component of peat compost. Next slide, please. Peatlands also support a small number of carnivorous plants, including the sundews pictured. These trap flies on their sticky leaves and slowly ingest the nutrients from them. Other insect-eating plants of the bogs are butterworts, and in pools, the bladderworts. In a few Irish bogs, pitcher plants have even become established, native to Eastern America. And last slide, please. So the other highly important property of peatlands is their ability to store carbon, and it's been estimated that the peatlands of Eurasia and North America have 300 billion tonnes of carbon locked away, and this equates to 44% of all soil carbon. It's also estimated that the conservation and restoration of peatlands worldwide could reduce global greenhouse gas emissions by 800 million metric tonnes per year, which is equivalent to Germany's annual emissions, so a huge volume. However, their ability to store carbon does depend on their condition, and the more intact and functioning peatlands are, the more carbon they can store. External factors, such as erosion, as shown in the photo, can have a severe detrimental effect on them. Similarly, anthropogenic factors, in particular use for composting and fuel, can reduce their viability as functioning carbon stores. And that's the end of my talk.
Thank you so much for getting us off to such a strong start. I'd love to know what you think the best way to manage peatlands to maintain or enhance biodiversity and prevent carbon losses.
Well, in terms of management, they're best maintained through light grazing, particularly on raised bogs and blanket bogs, you know, very, very little grazing with cattle preferably. Fens need to be grazed a bit more heavily, but not too heavily. And fens also need to be cut on a regular basis, otherwise they just turn to scrub and woodland.
And do you think climate change is likely to affect the area of peatland we have in the UK?
It's not entirely known, as with many things with climate change, but it's thought that warming will gradually sort of deplete the examples further south in Wales and northern England, and there'll be a shift further northwards into Scotland and, you know, other countries in Europe, particularly Finland's got a wide expanse of peatland generally.
Mm-hmm. Well, thank you so much. We will see you again at the end. Just a reminder for everyone to please submit your questions for our panelists. Thank you so much, Chris.
Thank you.
So next up, we have Dr. Andrew Watson, quantitative horticultural consultant. That was a bit of a mouthful at ADAS Horticulture. Hi, Andrew. Thank you for joining us today. Andrew's background is in theoretical physics. His career has revolved around data analysis and computation on topics including food stability, allergy, and food authenticity. He became involved in data analysis for a DEFRA-backed sustainable peat alternatives project that ultimately brought him to ADAS and his work on designing novel substrates and carbon accounting. Looking forward to hearing what you've got to tell us today. I will disappear.
Okay, so peat is a wonderful substrate for growing things in pots. Peat is cheap, it's easy to extract, and peat is gone, and that is the opportunity and the challenge. And the big question is what to use instead, and the bad news is there is no simple single answer to that. There's no magic material that's just going to overnight replace peat. Okay, so we might look at some alternatives, and in the spirit of the times, we might also think about focusing on the sustainable materials, and that is the mandate of the project that inspires a lot of this work and that Lucy just referred to. And that was the DEFRA and HDB-backed CP138 as it's known. And that focused on 4 additional materials added to peat, which were wood fiber, bark, coir, and green compost on the basis that they are all sustainable. And the idea of that project and the work that's followed was to try and go a bit beyond the trial and error of growing trials to see if you can actually streamline the process so that you can work out in advance what combinations of materials actually work well instead of just doing growing trials, suck it and see, takes too long and too many fail. So can we do better than suck it and see growing trials? That was the objective. So I seem to have no power to move my slide. Okay, so we've measured properties. Oh, sorry, I'm going to go back. Okay, the strategy. There's an idea at the start of all of this that the physical properties of a substrate are essentially fixed. That once you've got the material, you can do things to it. You can modify its pH and nutrition to some extent, but you can't kind of modify the material itself. So it's kind of immutable. So that's the idea of it. The physical properties are the thing to start with. And the second idea is that there are 3 physical properties: the airfill porosity, dry bulk density, and the available water. And between them, they provide some sort of an adequate description of the substrate's physical properties. So one of those is basically how heavy is it, and the other 2 are the water holding properties. Okay, so let's run with that backdrop and see. First question, is there any pattern in these properties for the candidate materials? In other words, is there even any point in trying? And the answer to that is yes. What you see here is 100 or so raw materials supplied by growing media companies around the country. And those 3 physical properties are shown on a 3D plot for the 100 plus materials. On the vertical axis is the available water. And then the 2 sort of lower in the page, in and out the page, is the AFP, the airfill porosity, and the other, the dry bulk density. And there's different classes of materials here. The blue are coir, the black are peat, the kind of pink magenta is bark, the cyan is wood fiber, and the little green ones are green compost. So there is some kind of an overall sort of grouping, some sort of an overall structure. They're not just higgledy-piggledy all over the plot, but it's a little bit hard to see in 3D. So what I'm going to do is suppress the dry bulk density because it turns out that's the least important. And I'm going to show the same data, but in 2D. So it's exactly the same numbers, but just effectively projected along the density axis. And what you see here is a little clearer. The peats are in fact in 2 groups: the fine peats, which are around AFP of 10, coarse peats, AFP around 28 or so. The thing, the coirs and the green composts are hovering close by the peats, which is interesting. Another significant point is that the wood fibers and the barks cover a very, very broad range of AFP. Okay, so we'll come back to that in due course. So there's some sort of a structure going on. The second question is there any kind of way of linking plant response to these three physical properties? Can we draw a nice picture of that? And the answer is yes. And here's the nice picture. This is an example taken from that project, and this is coriander. And what you're seeing here, there's no dry bulk density, but what you're seeing here is plant response versus the AFP and AW. So yellow is a good response, blue is a poor response, and you can see a sort of gradual slope towards from a high AFP towards the low AFP and corresponding AWs. The little circles are actual data points, and some of those are raw materials and some of them are mixtures. The little lines are the error bars. So the low AFP, high available water is the target, and that's where the fine peats live. So that's where we would like to be. And this is an example from the herb sector, but other plants show broadly the same structure, but the slope of that kind of surface just changes a little bit depending on the plant type. Okay, so that's looking quite promising. So what does that give us? It gives us properties that can be measured in the lab. And when you've got those measurements, you can see straight away, is that material going to be useful as a substrate or is it not? Also, the physical properties of mixtures, as you saw in the previous picture, they kind of fall broadly as you would expect. So they're not just all over the place. They do have some sort of systematic way of being combined. The plant response also varies sort of smoothly and consistently with property values. And what that means is that you can generate, and we've done this, you can generate a predictive model of how a plant will perform given different substrates and measurements on that substrate. And what that means is you have a way of designing new substrates, some sort of rational design process instead of suck it and see and crossing your fingers and hoping it's all going to work. And it also comes with it an alternative view of substrates. Now, okay, so some people wouldn't like me saying this, but I've said anyway, mixtures based on recipes should be banned. Ooh, that's harsh. But the reason is this, that the wood fibers and bark, remember, they're covering that wide range of AFP. What that means is that it's not enough to say 70% wood fiber because your wood fiber may not be the same as my wood fiber. They are completely different potentially, as those ranges of AFP will show. And the same is true of barks. Why hasn't this been such an issue before? And the reason is that the peats and certainly coirs are quite compact in their cover of the AFP axis. So it doesn't really matter quite so much. But now we're starting to look at these other materials, the wood fibers and the barks in particular. It's not enough to have recipes that just say some percentage. The other thing that's really a bit weird, and in fact is quite deep, and that is that when you have physical properties, physical parameters of two mixtures, that means that we can say, when they're the same, we can say those mixtures are the same. So for example, you could have a mixture of a green compost and a bark, and another mixture of a peat and wood fiber. And if their three physical parameters are the same, then those mixtures are the same in that sense. It doesn't make any sense to do it without the physical parameters, and we haven't had that capacity before. Why does it matter? Because if you don't have a way of saying how or comparing two blends to say they are the same, you do not have a way of saying one is better than the other. I'd like to contrast that with an old view, which would give you the observation that there's no way to compare results from growing media trials, because you do not know if the wood fiber you're using this time is the same as last time. There's all sorts of other factors involved in the growing trial, the weather, the husbandry, and so on. And the other aspect to that is that it seems a bit curious when you look at it in a different way, that you're using plant response to test the growing media when you could be doing those measurements in the lab. And the plant response test using growing media of growing media means there's all sorts of other factors to confound your conclusion. So it's probably best avoided. So last comment though, having said all of that, there is still no replacement for an actual growing trial. The objective of the work was to streamline that process and to remove the need for trials that would go nowhere. And a bit of maths and some nice plots will never supplant the skill and the experience of you growers and substrate producers, but hopefully we can make it a bit easier for you. Thank you.
Thank you so much, Andrew. One of your plots showed some green circles for green compost close to the points for peat and coir. Does this mean that green compost is a good substrate?
Interesting question, Lucy. Now, in terms of its physical properties, the answer is yes. In terms of its practical use, it has some challenges. It has got a bad reputation, and some of that is justified. Its chemistry is suspect at times. The variability is a problem. However, it ticks a lot of environmental boxes, and if some of those problems could be dealt with, that would be very desirable. As you say, it sits in the plot alongside or close by peat, and in that basis, it is a very attractive material. But there are problems.
And what about other commonly used materials, sand, vermiculite? Where do they fit in?
Okay, so those were, again, in terms of the original project, were seen as not sustainable and also totally different type of material. So we stuck with the plant-based, plant cell wall-based materials, and that allowed us to make quite a lot of progress, in particular in terms of combining properties, but also respecting the sustainability angle. And those are, as you say, often used for particular reasons, but they don't really lie within the scope of the work that we've done to date.
Mm-hmm. Okay, thank you. So we will see you again after we've had our last panelists for our group Q&A session at the end. So next up, I'm going to ask Dr. Jill England, Head of Horticulture at ADAS Horticulture, to join us on screen. Hi, Jill.
Hi.
So Jill is a plant physiologist and horticulture consultant with a focus on resource use, including plant nutrition and growing media, and more specifically, the reduction of peat use in growing media for the ornamental sector. Thanks so much, Jill, for joining us, and I will disappear to leave you to it.
Thank you, Lucy. So today I'm going to talk to you quickly about peat use at the moment in the UK, and then again look at CP138 and the implications for growers, then consider some of the big questions that remain and what are the next steps, what work is currently going on. So peat, how much peat are we using at the moment? So looking at this table across both the amateur and professional sectors between 2019 and 2020, we can see that the proportion of peat used has reduced, but we can also see that at the same time, the volume of peat has increased. But we do know that the reason for that is the greater interest in growing and in gardening that we've seen in recent years. Taking a closer look at the materials used by the professional sector, we can see that peat is the dominant material still used, and common other materials remain coir, wood fibre, bark predominantly, but also a very small amount of composted green waste. So the implications for growers. Well, as Andrew said, CP138 has shown us that we can use peat reduced and peat free blends to produce good quality plants. But really what we would say that when you're changing, when you're trying to use different materials, it's a very good idea to learn how to use those materials and work out for yourself what is the best way to manage them on your nursery. So considering watering plants, for instance, with these new peat-free materials, we can see that on the surface very often it can look very dry, but if you take that plant out of the pot and have a closer look, you'll see that beneath that there's still quite a lot of water within the pot and within the media. So really you need to make the decision at that point whether or not to let the grey media dry back further or whether it is time in fact to irrigate. And these are decisions that need to be closely monitored before you take them. You can also look at the nutritional status. Just keep looking at those, because we found that in general, you don't need to make any nutritional modification, but for other medias, you do need to. So there's no common answer. You need to use these materials on your nurseries and understand how they behave, how they work, and how you can make them work best for you. So talking about the machinery that you use on the nursery, we found that peat-free blends tested on grower sites were generally suitable for use in potting machines, and we saw not too many problems. But when you consider the propagation stage, it can be more problematic, and we found that sometimes because you need small, fine particles in your growing media, it can be more problematic, and we can find larger particles that might need to be taken out. So that's something to keep an eye on, and an area where perhaps more work is required. You also need to consider the flow rates that you use, and these may need to be altered to get the best fill. And so the big questions, we're hearing more and more growers saying that they are ready to make that switch to completely peat-free growing media. But then for others, they're less confident. So it may be that there's more support needed in this area. And another big question, which we've been hearing about since way back in, say, 2011, when these reports were first done on this subject, that there isn't enough volume of the different materials to replace total peat use. And so that's an area where the growing media manufacturers are doing more work to try to source and find alternatives that would give good quality growing materials. But do they offer consistent quality? This is another question, and this is why I think we're generally less keen to use composted green waste in professional ornamentals growing, for example, because we often find that consistency just isn't there. You know, which is something that we've really been pleased to see, and that's made using peat so much easier. So any materials that we do find and that we do use, they do all need to be traceable to source, and that's another area that can be difficult. So what's the environmental impact of these alternatives? So the responsible sourcing calculator has been under development for a number of years under the auspices of the Growing Media Association and the HTA, and we're hearing that this is almost ready now to launch. And this looks at 7 different environmental factors like water use, energy use, habitat and biodiversity, renewability, for example. But all of these materials that we use now, the coir, the peat, the green compost, they all score differently on these, and some score better in some areas than others. For example, coir has a worse score on water use, uses more water in the manufacture, but peat, we know, of course, has more problems, particularly in renewability. But one of the materials that works better, scores better in this calculator, is composted green waste. So we've heard from Andrew that there are reasons why this would be a useful material that we could use in the future. In terms of the environmental impact, again, it scores very well. But we just need to iron out some of these inconsistencies in the quality. And if somebody could do that, then this would be a great material that could be used in the future. But challenges do remain as well, in terms of, particularly in terms of propagation, and looking at blocking compost replacement, replacement mushroom casing, and propagation where you might be using very small cells, particularly in ornamentals and vegetable propagation. So yes, work is still ongoing, and at the moment we are looking more closely at the area of propagation in vegetables, forestries and ornamentals, and a lot of this work is demonstration trials. So here I think growers will find that they can start to hear from other people how they can increase their confidence in using these different materials, how to use them better, and just I think generally get some discussion going and understand from the work that's carried out how best to use the materials going forwards. That's the end of my talk. Thank you.
Thank you so much, Jill. That was fascinating. I was wondering what is driving the current impetus for growers to move away from using peat?
Well, I think one of the most immediate pushes has come from the fact that Bordemona in Ireland have stopped harvesting peat. So they stopped at the start of 2021. And so although now and in the near future we're actually gradually working through the peat that was harvested up until then, there will be a time when that comes to an end. And so what that means is that there's less peat in the system, so increased use of alternatives. And I guess the price of peat will be going up as it becomes less available. And so that means that in the long run, the cost of peat and the cost of the alternatives will be nearer to parity, whereas in the past the alternatives have been quite expensive, and that's made it difficult for growers to use them, particularly when margins are very narrow.
And can we not just use peat from elsewhere?
Well, in theory you could, but that would just be pushing the problem onto somebody else, really, wouldn't it? It would also mean that that you'd be transporting peat all the way from, for example, Lithuania. So then it would be going across the sea, it would be going on rail, it would be going, on roads. So that would have an additional environmental impact. So it's just coming further. And I think as well in Europe, they've got the same ideas as us. Other people also want to be reducing their impact on the environment and using less peat.
Mm-hmm. And I guess a similar question, can't we all just use coir?
Well, we might want to, might like to, I guess, but again, there just wouldn't be enough of coir to go around. There wouldn't be enough to replace peat. So you need to manage the risks, really, don't you? So if you put all your eggs in one basket, if everybody wants to use coir, then you just need to have some problem to happen that you can't import it all the way from Sri Lanka or India or whatever. It would just create havoc in the system, really, and that would harm horticulture. So really, I think going forward, it's more likely that the mixes that we use will use a range of different materials, some of them at quite low volumes, and that helps to spread that risk.
Yeah, I guess it's vital to ensure a stable supply chain.
Yeah, sure.
Thank you so much for your talk. I'm going to ask you to stay on screen as it's now time for our Q&A session, and ask the other two panelists to join us. We have had quite a few questions through, but please do keep them coming, as we've still got some time to go. So hope to make our way through as many questions as possible. So the first question we have through is, what are the target physical properties, and will these be specified by producers?
Is that one for you, Andrew?
Are you going to ask a particular one of us, or who do you have to fight it out?
Some of them are specified for individuals, but I'm going to open that one up to the group.
Do you want me
I think I'll say something first. Why not? It's pretty clear the kind of general sort of range of numbers that you would like to have. We've actually been talking about this, because if you go to your garden centre or whatever, then there's bags of compost, as it's called. And how do you pick one from another, apart from price? What have you got to go on? Name, maybe, price, but not much. It's possible that you could have numbers on the side of the bag which would give you some sort of an indication of its, for example, its water holding capacity. I mean, the kind of parameter that I was describing earlier. You could have one or two about its key chemistry, and that would be actually quite helpful, because you've got something else to make some sort of decision on, because some plants are more demanding than others. Some of the ornamentals, for example, very demanding. And that gives you an idea of, well, I'm prepared to pay the extra couple of pounds for this bag because I'm trying to grow pansies or whatever, and I know that I'm going to have to pay just that little bit more. I liken it to the numbers that you see on the oil that you buy in the shop for your cars. It's got some sort of a code, 20, 50, 30 or whatever. You could do something similar to that. But in terms of, you know you want to have a low AFP, you want to have a high AW, available water. For some purposes, you need some sort of a density because otherwise pots blow over. But there's fairly well-defined regions to aim for.
Mm-hmm. Mm-hmm.
I think. Sorry,
Sorry.
I was just going to say, I think for me, that it also depends on, you know, what is the system that you're using on the nursery, and so the growing media that you want to use as a professional is going to be the one that will fit the system that you have, and it's going to be different if you have, for example, an ebb and flood system, or if you have an overhead irrigation, if you're growing indoors, if you're growing outdoors. So there are so many different variables there. And so the manufacturers, they are the ones that will be using the tool that Andrew's produced, and they'll be using that tool to define the type of material and the parameters of that material that the growers will need to use for certain situations. So I think there will be some discussion and two-way between the professional growers and the growing media manufacturers in terms of where they're using it and the sort of media they're using. And particularly if you're growing for a supermarket, that's going to include questions about the environmental impact. So they might have a push that comes from the point of view of the responsible sourcing calculator. So they will also be putting other pressures on to say, we want this level of not impacting the environment, for example. And so you've got to kind of find a middle point with all of those different areas where they meet in the middle. So I think you know, those are the things that will be considered. But really, it's going to come first from the manufacturers in terms of the structure of the growing media.
Mm-hmm. Mm-hmm. Chris, did you have anything to add? If not, we've got plenty of other
Not
questions.
really, not on that.
Okay, so the next question we have through is, how long will it take to trial a peat-free compost before it could go to market commercially?
I think that's a question for a growing media manufacturer.
Okay.
And I think that's probably true because you know, we can do trials in terms of the substrate and the substrate in terms of the structure of the substrate, the materials and the blends that you might need for a specific purpose. But then on top of that, because in that particular project and using the model, you're not actually looking at nutrition. So then you need to get the right nutrition that fits with the materials that you're using.
Mm-hmm.
I think it's worth saying in that project we were able to produce blends that were used on grower sites very successfully. And because they were having to fit in with what the growers were doing on their own sites anyhow, they were aware straight off that in fact, had they had the latitude to modify the husbandry, they could have actually done better. So some of the blends were actually very successful. But I guess you'd want to go through a couple of iterations of that sort of process. And of course, especially on a big commercial site, there's a huge amount of money at stake. So nobody is going to risk using some sort of a system that might go wrong on them. The potential loss is just too great. So there's a confidence issue, which I think is a very tricky thing. It also makes a big difference. Are you talking about the commercial sector or the amateur sector?
Mm-hmm. The next question we have, I'm going to direct to Chris to answer first, and then if anyone else has anything to say, what proportion of peatlands are subjected to peat extraction?
Well, it's decreasing anyway, and as Jill said, Bord na Morna in Ireland have now basically changed from peat extraction to peat restoration, and that seems to be, you know, reflected across the UK. I mean, Ireland I have seen commercial peat extraction in Scotland, again up in the Flow country in the past, but I think most of it is coming to an end now on that kind of scale anyway. It's surprising how many turbary rights still exist though. I used to live on the edge of Borth Bog, or just near Borth Bog, and apparently we had turbary rights, which is, you know, rights for digging for peat. as part of the house sale, but we never used them.
I thought most of those had been withdrawn.
Well, yeah, I expect. I mean, this was 20 years ago, but yeah, in general, you know, a large decline in commercial peat extraction. You know, 30, well, even 10 years ago, you would have seen large areas towards the west coast of Ireland where, you know, you'd get miles of bare peat. But as I say, Bord na Móna have, you know, completely reversed their approach now.
Well, that's good to hear.
And hopefully that's replicated, you know, across the world to a certain extent. As you say, I don't, well, I'm not entirely sure, but in terms of Europe, Finland's got the highest percentage of peatlands per land area. And I don't think much peat extraction goes on there. I think, but yeah, it'd be something, yeah, interesting to find out anyway. But.
Thank you. Andrew, I've got a specific question about your research. Was digestate looked at in your research at all as a potential product to use in composts?
Yes, it was, and it came out pretty poorly. It's the short of it. And if you like, that's one of the attractions, because that 3D plot that I showed, if a material shows up in the wrong part of that plot, you know straight away you've got a problem. That's the power of it, really. Without having the physical properties, you can't actually show a bunch of different materials on the same plot and make some sort of a comparison, visual or otherwise. So yeah, there were a couple of digestates around, and they were problematic.
Mm-hmm.
A lot of the wood fibers were problematic as well.
Good to know. So the next, Jill, I've got two questions for you. I'm going to combine them. So the first one is, do you recommend using wetting agents in a peat-free compost to help with water retention within the pot? And the second one is, are there any biological amendments or inoculants that we should be using with peat-free media to make them more reliable?
Oh, okay. I think in terms of wetting agents, one of the things about peat is that when it dries out, it's more difficult to re-wet, because what you find is, you know, it dries out in the pot, and you put water in, and it literally will drain through rather than being held onto and be taken up by the peat. So, you know, that can be a problem, but that's less of a problem with some of the peat-free compost and the peat-reduced compost. So I think something like Korea, for example, we know very well that re-wets very easily, because that's transported to the UK in a dried form, and then you get it to the UK and then you wet it, and then when it's fully re-wetted, then you can start to use it. So, you know, you think, yeah, no, it's not so much needed there. So I think those are the two extreme positions. So you're less likely to need so much wetter, if any, in a peat-free compost, but it's always going to depend on what the final mixture is.
Mm-hmm.
You know, have you gone peat reduced? Have you gone peat free?
Mm-hmm. And then
sorry, the other question.
Do you want me to remind you of it? Sorry.
Yeah, go on.
So it was, are there any biological amendments or inoculants that we should be using with peat-free media to make them more reliable or aid nutrition availability?
Oh, right, okay. There's a whole range of different amendments that you can use. For example, you could use, as is often used now, particularly in larger pots of longer-term crops, like I suppose trees and longer-term shrubs and so on, particularly, then you might use mycorrhiza and so on. But I think there are other amendments that you can use that would help with nutrition, but I can't name any off the top of my head at the moment. But if anyone wanted us to, we could get back to them on that and give them a bit more detail. If people wanted to contact us, that would be a really good contact point.
Okay, that's great to know. And then, so the next question I've got coming up is actually a follow-up, Andrew. What were the issues with the digestates that you were just talking about?
it was just simply the case that the physical properties were poor, no more or no less than that. So on that plot, they were in the wrong place completely. So we didn't do anything more with them than that. Okay, so I can't tell you anything further than that. I got 3 numbers. They're in the wrong place on my plot.
Okay. So the next question is sort of off the back of that one. What is the chemical element of peat that we are looking for to replicate?
One of the, I'm going to jump straight in on this. I can't resist. One of the things, again, about the plot, all right, if you got 2 materials there and there, and you combine them, you're going to get something in between. If peat's up here, you ain't never going to get that. You can't make peat from other things when they're in a different part of that plot. So trying to sneakily combine some bark and some wood fibre on a 5 o'clock on a Sunday afternoon, hoping you're going to cheat the system, it won't work. So I'm not so sure that replicating peat is really the objective. I mean, it is a very fine substrate. It's perhaps more successful to think in terms of finding some substrate that will do an adequate job, but simply looking for the magic component of peat and thinking that you can somehow find that and extract the essence of peat. I don't think that's going to be a very successful approach. I think it's certainly interesting to understand exactly why peat is so good. I mean, that's really a very interesting question. But in a sense, it's slightly academic because peat is peat, and you are going to have a hard time replicating the exact properties using other materials, if that makes sense.
Mm-hmm. And Jill, were you going to add something?
No, I think what I heard you say was replicating the chemical properties of peat. In which case I was going to say, I don't think it's necessarily the chemical properties that we're looking at here, it's the physical properties.
The physical properties. Next question. Does the particle size of the substrates heavily affect the air-filled porosity or the water holding capacity?
Yep.
Yeah. This is great. We're moving through these at the speed of light.
That's a simple answer, yep.
Did you want to go into more detail about that?
Well, I suppose it's a bit of a wide subject, but if you take a particular material and mill it down to make it smaller, then the smaller version is effectively a different material. The refined version is effectively a new material. That's one of the consequences of the approach. If you take something and it's a material A and it inhabits a certain spot in a 3D plot, if you grind it down to a finer size, it becomes a new material. It inhabits a different point. But the finer materials tend to do better. But there's more surface area. Of course, that's not really so surprising.
I suppose it's a little bit like the difference between clay and sand, isn't it? You know, sand is bigger particles, and got a higher, or bark. Let's say bark and clay. Bark would have much higher airfield porosity, much more air in between, but the water's going to go through it much more quickly and perhaps too quickly in some cases. The same with sand, so it'll be draining out and it'll also be taking nutrients like mobile nutrients like nitrogen with it. But then if you've got something like clay, well, that might be a lot better insofar as it's got very small pores, and so it might hold on to water more, but at the same time it does it too much, and then the roots can't really get the proper sort of access to to get in through the pores. So, and there's not enough oxygen in there because the roots need a mixture of air and water. So it's about getting that balance right and the balance of particle size in the material that you're using. And that's what creates the airfield porosity that you want. And of course, that airfield porosity is going to be different, or what you need for that is going to be different depending on what you're doing. So some of the bigger, longer term crops, you want perhaps a bit more of an open growing media, particularly if it's outside and it's going to get rained on and everything. You don't want it to stand too wet, so you don't you know, so you've got to try and get that balance right again.
Mm-hmm.
And then if you've got something like blocking compost, you want something really fine that's really going to hold together properly.
Mm-hmm.
It's probably also worth saying that porosity in peat soils probably, well, I'm not sure about this, but I think there's a wide variation within peat soils themselves. You know, certainly there are different layers within peat bodies in intact peatlands.
It's true. Certain layers are used for certain applications.
Yeah.
So the mushroom guys use a certain layer of the bog.
Well, it's the Van Post scale, isn't it? And that's how it's graded out. Whether it's the very old, very dark peat, which is very close together, which is more the sort of thing you'd use for blocking compost, or it's some of the younger peats, which you might think of or call the white peats, you know, which are perhaps used more generally. You know, for a less narrow reason, or perhaps, you know, mixed. So you know, you'd have a mixture of peat sizes in a growing media to create the airfield porosity that you want.
The next question, it's sort of more of a comment, but I think it raises a really good point. The question talks about Ireland is still exporting thousands of tons of peat per year and is now importing peat for horticulture as well. It would be great to see a big EU project on peat-free growing media, as there are lots of peatland restoration projects happening, but not dealing with that aspect of it. So I think what perhaps would be a good question to answer is, are there any EU projects dealing with peat-free growing media? And if not, do you think it's likely that there would be cross-country collaboration?
Well, I know the Growing Media Association has links across Europe, and so they talk and discuss things with Europe. There aren't any projects that we as such involved in, but there may be others that we're not aware of or you know, don't know about as yet. So there could be some, but it would be a great thing to do. So I know there's been sort of collaboration and discussions on the whole peat reduction discussion across the UK and between the UK and Europe.
And then
oh, sorry, I was going to say that I know, and as well, you know, we do at times have people from Europe come across, and from the European Growing Media Association, and they come across and they speak at some of our talks. So, for example, the BPOA and so on, and the IPPS.
And the next question we've got is, given ambitious tree planting targets, both nationally and internationally, to tackle the effects of climate change, is it feasible to find peat alternatives at this required scale for growers to meet demand?
Well, we were talking to some guys about that just earlier today. So hopefully the answer is yes, but we're working on it. Actually, there's a serious point here. When you have, for example, trees or any of these other planting out scenarios, for example, vegetable propagation, they start things as seedlings in little containers. And that really adds a whole new layer of complexity to this issue, because then you need to have a substrate which has got certain desirable mechanical characteristics so things can be planted out in the fields, for example. I mean, Jill mentioned blocking peat. Well, that's used in the vegetable propagation sector, and they plant these things out in the field at the rate of 5,000 an hour, these little lettuces and things. It's very, very streamlined, and peat works just fine, and you take the peat away, and suddenly the entire enterprise basically is under threat. And they have the similar sort of problem with some of the tree propagators, because they're propagating in small containers. Any of the small containerized stuff, its mechanical handling is an issue. The tiny amount of material is an issue. The replanting, it's actually quite hard. So, you know, folk who write in some magazines saying that peat replacement is easy, that's actually not true. It is actually quite a challenge. Especially in those sectors.
On a related subject, with tree planting, you know, I wouldn't like to see that take place on existing semi-natural habitats, including peatlands. We did some work in Ireland monitoring semi-natural habitats, and occasionally under agri-environment schemes, occasionally you'd get tree planting, which had been directed away from the productive farmland and planted on, you know, an existing fen or something like that, which is completely unacceptable, really.
I'm afraid that is all we actually have time for. We do have quite a few other questions that have come in, so we are going to try and get these answered after the session finishes. Thank you so much, everyone, for joining us today, and to our fantastic panelists for sharing their insights. As we have heard, peat is a very valuable resource and especially important to the UK, considering how much of the world's peatlands reside here. Obviously, it's a hard challenge to phase peat out from commercial use due to this very value. But, you know, it seems thinking outside the box to design these peat alternatives is key, as is dedicating resources to find sufficient volumes of these materials and ensuring growers have access to education to trial their own blend. I hope you all come away from this session feeling as hopeful as I have. Just a reminder to please fill out the feedback survey that you're going to receive in an hour after the webinar ends. Our next topic in the Green Dialogue series is on the 10th of February at 3 p.m. and it's about regenerative design, building the future we need. So hopefully we'll see some of you here again. And for more details about the webinar and to book, please visit the RSK website. The link is in the chat box. Thank you so much again to our panelists. Your insights are invaluable, and thank you to everyone for joining.